graph just one inequality on a coordinate plane. Do you guys remember that you have a certain type of line? What were the two types of lines you could have? There's a and a. Yeah, you have a solid line or you have a dashed line. And then you also must do this. If you want to get the solution to an inequality, you have to do what? After the line, you have to do something else. I think I heard it. Shade. You guys shade a region. So an example, you don't have to draw this, but if I have a dashed line, let's say it's this. For just one inequality, you'd have to shade a region based on the inequality sign. So that's what your one inequality with two variables would look like. But now we're talking about systems of equations. So what does that mean? What does it mean by systems? Yes, ma'am?
You have multiple lines.
Multiple lines. Yes, you have to find out what are the solutions to both. In this case, we're going to deal with two. So let's go to example number 1 and see how these problems look, the most basic forms of these problems. So example 1 on page 482, the very bottom. It says solve each system of inequalities by graphing. And some of you have been doing this like on a quiz or test, and I like it. So I'm going to write it. Y is less than 2x plus 1. And then I'm going to write the other equation or inequality over to the right of it. Kind of write it this format, which is good because you can work down. Okay, before you graph an equation or inequality, what do you have to do to these inequalities? Do you guys remember? You have to get it into slope-intercept form, which basically means you have to solve for y. So I got y by itself on both of them, right? So I'm done. And just as review, because this is what I saw in your quiz, you can get it into slope-intercept form, but you use the wrong slope or the wrong intercept. So here, I'm going to call in some people, and there, you're going to identify the slope and or the y-intercept. So on this equation, Brian, what is the y-intercept? Where does it cross the y-axis?
1.
At positive 1. Good. Rosalind, what's the slope of this inequality?
2x.
Give me just a number of the slope. Good. 2 over 1. 2 over 1. And if you're like, where does that 1 come from? If you write it as a fraction, you get it. All right. On this second one, Nate, what is the y-intercept?
3.
Positive 3. That's where it crosses what? The y-axis. So please don't forget, because some of you are starting on the x-axis, and that's not how you do it. All right, what's the slope here on this second inequality? Lily?
Slope?
Mm-hmm.
It's 1 over 1.
Yeah, it's negative 1 over 1. So there we go. We got it in slope-intercept form. We have everything we need. Go ahead and graph it on your paper. Thankfully, you won't need to have graph paper necessarily, but I will give it to you at the end. So we're just going to graph these, make sure they're all good. And don't forget, they have to be dashed or solid depending on the inequality. And then we'll talk about the shading aspect because we still have to do that. I'm going to graph the first one. I start on positive 1 on the y-axis, and then I go up 2 over 1 to the right. Up 2 over 1 to the right. Up 2 over 1 to the right. Or I can go down 2 over 1 to the left. What kind of line should that be? Dashed. So make sure that it's dashed on your paper because it just says less than, not less than or equal to. That's the first first inequality that's graphed. What region should be shaded if I just had the first inequality? If I just had the first inequality, what would I have to shade? Above or below the line? I know Jenna knows. Lily here up front?
Below.
You'd have to do below. But are we just talking about one inequality? No, we're talking about two. So I got to get this graph on there as well on the same coordinate plane. 1, 2, 3. I start off there on positive 3. I go down 1 over 1. Down 1 over 1. Down 1 over 1. Up 1 over 1 to the left. Okay, what kind of line should that be? Solid. And if I were just graphing the solid line, what region would I have to shade? Above or below it? Above it. Okay, bless you. But I want to solve the system of inequalities, so I have to find out, all right, what region would fit both of these at the same time? So there are 4 regions normally you create. I'm going to call this region A. I'm going to call this region B, C, or D. Okay, so this is A, all this right here. This is B, all this right here. C is all this right here. And D is that bottom region there. Which region should be shaded completely? Fits both of them at the same time. Yes, ma'am? Region A. Okay, hold on. This part right here? Okay, is this part less than this inequality? Yep, it's below this dashed line. But is it also greater than the solid line? Oh, it is. So that is the region that fits both of them at the same time. So region A on that. Now, you don't have to call them region A, B, C, D. I do it so we can point it out together. But do you guys see that that would be the solution? Okay, but just like some of you did, which was really cool to see on your quiz, you checked your answers. You can check inequality answers. What is one point here in the shaded region that should work? So give me any point over here that should work for both of those. So give me a point. Matt. 1, 2, 3, 1. So yeah, right here. So I'm going to put that 3, 1. Should 3, 1 be a solution according to my graph? Yes. That also means it should fit both of these at the same time. So what's 2 times 3? 6. 6 plus 1? Okay, this is 7, and that's 1. Is 1 less than 7? That checks. So it fits the first one. But don't just check one of them, because could it fit one and not the other? Yeah, it could have been in here somewhere. And any numbers here could fit the first one. But it has to fit the second one as well. All right, this one's 1. And what's negative 1 times 3? Negative 3 plus 3? Is 1 greater than or equal to 0? Yes, that also works. So that region works. Yes, ma'am. Right here? This? You start here on the origin, you go 1, 2, 3 to the right, then up 1. So it's 3, 1. Yeah, so you go right. Oh, like right here? Gotcha. And you don't need to know where they met on these problems, only on the equations. Okay, can I ask you this question here? Looking at this point where right here, this point right here, should that be a solution?
Yes.
What's that point? 1, 2, I think. It's on the line. Okay, it's on the line. Okay, does 1, 2 fit? What's 2 times 1?
4. 1, 2.
2 times 1. Sorry, it's early, right? 2 times 1 is 2. Plus 1? 3. And you have 1? Is 1 less than 3? Whew. Okay, what about down here? You still have 1. And what's negative 1 times 2? Negative 2 plus 3?
1.
Is 1 greater than or equal to 1?
Yes.
Oh, so it does work. Check. All right, that point will work. Would any of these points work on the line? Yes, any of these points would also work. What about this line?
No.
What? What's wrong with this line? Dash. Dotted, dashed. Try to combine those words. All right, let's pick this point because I really think it should work. That would be 1, 3. So I'm going to scratch these out so I don't confuse them. Okay, maybe not. Oh, I got to get used to this. 1, 3. All right, what's 2 times 1? 2. 2 plus 1?
3.
Okay, is 3 less than 3?
Yes.
Sorry? No. So does it work on that first one? Nope. And even if it works on the second, it's not a solution to both. Sorry, that's right here. Do you guys see how you can check them? How many answers are there, by the way? Infinite. Yeah, it's technically infinitely many. Is it any answer? No, but it is infinitely many because this region keeps going on and on into infinity. Okay, let's do another one on B. You just mentioned infinitely many. Do you guys remember that other weird solution you can get? No solution. So I have here 2x plus y is greater than or equal to 4. And then y is less than or equal to negative 2x minus 1. All right, what's your first step on these problems? If you want to graph them, you must do this first.
Slope-intercept form.
Slope-intercept form, which basically means solve for y. Okay, is this one solve for y?
No, I mean,
Yeah, you subtract 2x from both sides. You get y is greater than or equal to negative 2x plus 4. What about the second inequality? Is it solve for y? Yes, so you're done with that one. Now it's time to graph. Anyone notice anything about these graphs before you even graph them?
they're not perfect.
They have the same slope.
They have the same slope. What does that mean then?
They're going to be parallel.
They're going to be parallel. Okay, so I hope I graph them so that they look at least partly parallel. I will start with this inequality here. Where do I start my graph, Emery? Where do I start my graph here?
-2.
Excuse me?
-2.
Positive
Oh, +4.
on the y-axis. Good. 1, 2, 3, 4. Got to start at positive 4 on the y-axis. What's the slope on this one?
-2, 1.
Okay, so I go down 2 over 1, down 2 over 1. And what kind of line is that going to be? Solid. Good. Solid because it says equal to. So it's a solid line. All right. The second inequality starts where, Autumn? So this one up here. -1. So on the y-axis, -1. And what's my slope, Carson? So I go down 2 over 1, or I can go up 2 over 1 the other way.
Can you count in the 2s?
Nope. I'm counting by 1, so like this slope is down 2 over 1, down 2 over 1. Okay. Now, yeah, they don't look parallel, but they should be. Thankfully, we'll have some graph paper. What region should be shaded comparing this bottom line? So you're like, which one is it? It's this equation. So you got to shade above or below it, technically?
Below it.
Below it. You should do a below it. Below it. Okay, what about this other inequality? You should shade above it. Are there any solutions that would fit this inequality and that at the same time? And the answer is no. So what's your answer? No solution. There are no numbers that would fit both of them. Or you can write that. No solution. You can't have a number that's greater than this line and at the same time less than that line. Have we seen those kind of answers before? Do you guys remember the absolute value inequalities? Do you remember how you can have no solution? Same thing up here. So there you go. No solution. Does that happen? Yes. So be ready for it. Okay, I want you guys to work on number 7 on page 485. Let's see if you guys can figure this out. And if you need help, I'm available. Yeah, so is there an X already? Nope, so it's a special line. It's either going to be horizontal or vertical. Do you remember which one it would be? Yeah, get it. If you have an X, yeah, get it. Away from Y. So, this line right here, where does y equal -2? Like right down here?
Mm-hmm.
So it's going to be a horizontal line. And don't forget it's dash or solid. All right, that second inequality should be pretty easy to graph after you solve for y. But this first one, do you guys remember what kind of line that has to be?
Vertical.
Which one?
Horizontal.
Yeah, horizontal. If y and is equal to something without an x, then it's going to be this horizontal line that goes through y equals -2. And I'll extend these lines. So you can see that there are technically 4 regions. You have this bottom region, this right region, top region, left region. So which region would be shaded? So the right, the top, the left, or the bottom? Okay, here right. So this is how I check it. Is this region greater than the solid line? Yes. Is this region also less than the dashed line? And the answer to that is yes. If you want to check it, an easy point to use is right at the origin. So 0, 0. Very nice to use. So I'm going to pick 0, 0 just to see if it's right or wrong. Is 0 greater than or equal to -2? Is that true? Yes, that checks. Is 0 less than 0 plus 1? So is 0 less than 1? It has to work. That's the only solution. Or sorry, that is one of the points that fits both of them, and it's in that region. Okay? So you can check yourself on that a little bit. You guys okay with that? I think I know what to do. Go ahead and stand up real quick. Gotta get you ready for the pep rally. This is what I want you to do. These guys in this region, I want you to just march around these desks. Just march. Don't do it in unison if you don't want to. This group around this region, and you guys around this region. Just march. There you go. There you go. Good, good. I see them marching. I think the Spirit Week maybe drained them. I don't know, but they're doing a nice march. Harrison? Cross country, should we make you do some of the drills that we did?
No.
All right. All right, once you get back, as you march, once you get back to your seat, go ahead and sit down. Oh, hi, Jenna. Okay. Sorry?
I'm getting glitter all over the seat.
Oh, that's okay. Peter and who else is there? Yeah, Lisby, they'll forgive you, I think. All right. I want you guys to do number 10 on page 485, number 10. And I'm going to ask people different questions on that one. So I'm just going to call on each one of you for each step. See if you guys can get it. Number 10. start calling now. I know you're not done, but we'll just start from the beginning. The first inequality. What's my first step, Jenna?
You just add x to both sides.
Okay, add x to both sides. Y is less than x plus 1. Harrison, the first step on my second inequality.
You would add x.
Add x to both sides. Y is greater than x plus 3. All right. Nate, are these in a proper format to graph? What format is that, Alex? What do we call that format? What do we call that form? Excuse me? Close. Slope-intercept. So it's in slope-intercept. Good. I'm going to start my graph and continue to ask you some questions. All right, the first inequality. Turner, where do I start?
1 on the y-axis.
Good, 1 on the y-axis. And where do I go from there? Matt?
You go
Up 1 over 1 to the right, and I can keep doing that, or I can go down 1 over 1 to the left. What kind of line should I have there, Jack?
A parallel line, or a dotted line.
Yeah, this dash line. Okay, where do I start on the second inequality, Brian?
3,
3 on
the
1, 2, 3. Where do I go from there, Lily?
You go up 1 over 1.
Up 1 over 1, or down 1 over 1 this way. What kind of line should this one be on him? Dash line. All right. What region gets shaded on this one? Maggie? What region should be shaded? Yeah, there's no region. Good. No solution. How many of you got that? All right. This is what I want you to get. Even if you can figure out it's no solution, you still have to graph them, okay? If you just put if all you put is no solution and there are no graphs, that's not a correct answer. You'll lose points. And then don't shade anything because there's nothing that fits both of them. I have a little dilemma. So far do you remember this is our second problem with parallel lines? And what have both solutions been so far? No solution. Is that always true for parallel lines? You'll have no solution.
No.
Can anyone change 2 things to make this have a solution? So you can change the problem. You can do 2 things, 2 little things to change the problem, and it will make it a solution problem. I know these 3. All right. Jenna.
Y is greater than x plus 1.
So change this to greater than, and change that to less than. So yeah, what region is greater than this bottom equation? It's everything above it. And what region is less than the top inequality? It's everything. So it would have been this if you just changed those inequality signs. So you can get different answers, just our last 2 examples have not. All right. Number 12 is the last one we'll do together in class. Or excuse me, not number 12. Number 11 is the last one we'll do in class. And this is it. If you can get this one down, you're pretty set on this. I hope. Number 11. I'm confused too. Okay, hopefully you got y is less than or equal to negative 2x plus 4. Great. What happened here? I'm confused. That's my confused face.
I forgot to change.
Lily?
Since y was negative, you technically only solve for negative y, so you have to make y positive, which switches everything else.
Good. So I had to get rid of that negative sign. So I multiplied everything by -1 or divided everything by -1. But that changed the direction of the inequality, which will change your answer in your graph. So if you didn't do that, it makes the graph incorrect if you follow that through. Okay, so those are your two lines. They're both solid because they both have equal to signs. And then I want to go below this line and below this line. So the region that fits both should be this region right here. How many of you got that? Nice. How many of you didn't get that? How many of you got the equations other than this and you got a different region? Yeah, so that happens. It does affect your answer. So be careful when you multiply by -1 on both sides. Okay, I'm going to give you your homework. You can go ahead and get started. And then after lunch, I'm going to give you opportunities for bonus points on your homework. So what we've been doing is we've been graphing inequalities by getting the inequalities solving and then putting them on a graph. But you should be able to look at the graph and come up with the equations, or the inequalities, I should say. So we'll do that after lunch. Goodbye, Swivl.